All right. So in Monday's lab, we did what we call the motor lab. And we made a motor using this battery holder, right? And a permanent magnet, which is this little guy here. And actually, let me take this out so you can see. I have a permanent magnet here, right? Magnet, okay? Does all that magnety stuff. And what we're going to do is simply put the battery in the battery holder, right? And put the permanent magnet in. And we're going to use a coil of wire that I made, I don't know, 15, 20 minutes ago when I was trying to figure out how to record things on the school computers. It was every bit as exciting as you might think. I had to wrap the wire around a round object, and you're probably sad that you can't see that. But I did, and then what I did was I used a magic marker, and I simply colored over the wires at the ends. However, when I was done, I scraped one side of each wire. And the reason I did that is that now it's shiny here and shiny here. And so it conducts through this side of the wire, but it doesn't conduct through this side of the wire. So on this side of the wire, I want to be careful to make sure that it is completely covered in ink, right? So that it can't conduct. Whereas on this side of the wire, it has to stay shiny and clean. So it does conduct. So that's what I did. Then we simply set our wire here onto our rack and we turn it over. And when it gets to this position, right, when it gets to this position, it starts jerking around. And the reason is because when we run current through a coil, we know from last week's work that this becomes an electromagnet. Well, if it's an electromagnet, north is going to be on this side or on this side. It's going to be on the flat sides of the coil, right? There will be a north and a south, right, on either side of my coil, because we know that when we when current goes around in a circle, we end up with a north and a south pole, right? We did that. We tested that with a compass last week. So when I put it on here, there's going to be a north pole, say, over here, and a south pole over here. Well, this permanent magnet has a north pole that's sticking straight up, or a south pole that's sticking straight up. I don't actually know which it is. And it's going to attract one of the sides of the coil. We can tell which it attracts in just a moment. Put it on here, right? And suddenly, it looks like when I try to push it past this, it attracts, okay? Well, let's see what happens. It starts jerking even right now. I'm going to prop it up because I believe that is a thing. It needs to actually be balanced a little bit, but let's try this. Let's actually spin it a little bit and see what happens. It's starting to wiggle, certainly. Let's see if we can get it to turn all the way around. Let's see. And then you can see that it starts turning on its own. And I'll bring it back this way. Oops. Wiggling, but it's not turning. So let's see if we can get it to go. I keep on turning. There we go. And there it goes. Right? And if you look, we can bring this down here, right? You can see that it's spinning on its own because as the pole of the magnet, of the electromagnet, is attracted to the permanent magnet, it turns. But since it only conducts in one position, as it turns, it then blocks the electricity and stops being an electromagnet. So it keeps on turning through the rest of its circle. Right? Right now we have this magnet here, and when it's in this position, it has an electromagnet. And north here, right, is attracted down to the permanent magnet. Right? When it gets to this position, when it turns 90 degrees, it's no longer a magnet. And so it doesn't attract, it just keeps on spinning. When it comes back to this position, then there's a north again, right, north over here again, and it continues to, it gets jerked one more time, right, towards the permanent magnet. And so it keeps on going, being jerked when it's in this position, and then coasting when it's in every other position. And we can see this when we just let it turn a little bit. Let's see if I can get it to do it. Maybe I can. Looks like it wants to turn. It might turn. if that does it. There it goes. Right. So that's a pretty successful motor, and it'll just keep on going, right, while the battery is continuing to allow us to have an electromagnet as a coil. But we did do something else on Monday. So we played with the motors, and then we tried something else. So let me get away from this for a second and show you one more thing. Now, the other thing we did was we had a coil that I taped to a plastic cup, right, a food container, right? So here's a coil I made with varnished wire, and it's very thin, and I taped it to the bottom of the cup. This too can be an electromagnet, right? If I ran current through it, I would have an electromagnet. What I'm going to do instead is I'm going to run current from the microphone jack of the computer. So now I'll run current from the microphone jack into this. But one thing you need to know about the microphone jack is that it produces what's called an alternating current, that the current goes back and forth, right, depending on the sound that's being made. Sound has a frequency, and this current is going to have a frequency also. It's going to go clockwise and counterclockwise depending on the pitch of the sound, right? In other words, the more times the sound changes, the higher the frequency of the sound, the more times this current will change direction. So this magnet is going to have north and south alternating as the current alternates. And you'll see how this makes it work. So I'm going to hit play on this. Oops, I say I'm going to. Right, I'll just have something on YouTube, and I'll turn it on. Now you don't hear anything because it's not doing anything yet. Right? Well, that's because we don't have a permanent magnet near it to react to it. So let's see if we can get that to work. Let's see if this. Right. The answer is it is not. So why not? Oh, because I didn't hit play. Ah, sneaky. There we go. Let's hold it like this. Right? And so now we have a cup with a coil that's an electromagnet that has a frequency that's the same frequency as the sound I'm trying to play. When I put a magnet near it, it's either attracted to the magnet or repelled by the magnet, and the cup vibrates. Now, this is a more convincing demo when you're holding the cup and you can feel it vibrate back and forth and make a sound. Right? But you can actually feel the vibration two places. The cup is vibrating, but so is the magnet as the magnet's pushed back and forth by the electromagnet, a permanent magnet. Right? Now I can swap this magnet out for a slightly stronger magnet, right? And I get a slightly louder sound, right? And you can see this below. Right? Yeah, that's fairly clear, right? Now when I take the magnet away, no sound. Put the magnet back, and I get the speaker again. Okay? Anyway, so this is a speaker. It's a homemade speaker to be sure, but it works pretty well. And you might say to yourself, well, why don't real speakers work this way? Well, they do. And we can see this. Whoop, there goes our magnet. We can see this if we take an actual speaker. So here's a really broken up speaker that I bought at Radio Shack years and years ago. And you can see that it does the same thing, right? It's a speaker, right? And it's a little bit louder, right, than the other one because it's a little bit stronger magnet. It's got a lot bigger coil. right? Now I've turned it down, and you can hear it, right? So there's our speaker, right? Well, but where are the pieces parts of it? Well, if you look inside here, you can actually see the wires going down inside, and they wrap around, and there's a coil in the base of this. Well, where's the magnet? Well, if I use the paperclip test, which is the official test for magnetism, we can see that in fact I have a magnet as well. So this speaker is simply a coil of wire that's connected here to the leads and a permanent magnet. And when the coil of wire is attracted and repelled by the permanent magnet, it causes this paper cone to move up and down and make a lot of sound. Right? So speakers work exactly the same way as our cup speaker does. And so when we go back to this, all I need to do is have my alternating current, right? And I can turn up the volume a little bit. Right, and there's my speaker again. Right, pretty cool. All right, and so from the demos that we've just done here, you should be able to fill out the motor and speaker capture sheet that is in the module.